In this video, we're going to take a look at one last linked list question to really drive home the idea of this kind of dual pointer strategy for solving many different linked list questions. Inside my code editor, I'm going to find the from last folder, and inside there, I'll open up the index.js file. And then of course, before I forget, because I usually do, we'll flip on over to our terminal and start our tests up with just from last test.js -- watch, like so. And then we should see about 2 tests passing. Okay, let's take a look at our directions. So over in our index.js file, here's the directions at the top. So we're going to be given a linked list and an integer n. Our goal is to return the element that is n spaces from the last node in the list. One requirement is that we should not attempt to use the size method of the linked list. So this requirement is here because obviously we could probably think of a very direct solution to maybe get the length of the linked list or the number of nodes inside of it. We could then subtract n from that and then call get at on that number. So that'd be a very straightforward and easy solution. And obviously with interview questions, we're usually trying to find some challenge in a task. So we're not going to take the easy way out here by just using the size method. And in fact, we're going to try to come up with a solution that does not involve directly counting out the number of elements in the linked list at all. So I don't really want to worry about the number of elements in the linked list. We're going to try to think of some other way to get the nth element from the end. Now the other thing the directions say here is that we should always assume that n will be less than the length of the list. So in other words, if we have a linked list of 10 items, we don't have to worry about being asked for the element like 20,000 from the last element. In other words, don't worry about overflow here. N will always be less than the length of the list. All right, let's take a look at a diagram that's going to help to kind of clarify these directions and also lay out one possible solution to the problem. So here's our diagram. We're going to assume that maybe we get called our function with an n equal to 3. So the first thing to do here is to identify which element we should be returning. And I'm not talking about with code or anything like that. I'm talking about you and me looking at the diagram, which element should we return? So if n is equal to 3, we want to return the element that is 3 spaces from the last. So here's the last element right here. We're going to return 1, 2, 3. So this is the third element from the final in the list. To give you a more clear example of what this n right here really means, imagine if n equals 0, and then we said, I want the element that is 0 spaces from the last element in the list. So 0 spaces from the last element would be the last element. That's gray. If we then incremented that to 1, obviously that must mean the next element of purple. 2 would be orange, and then 3 again, obviously that would be red. So n equals 3 means give me red right here. Okay, so let's talk about how we can solve this by using this slow and fast strategy. Now this time around, slow and fast is a little bit of a misnomer. In other words, one pointer isn't necessarily going to be moving through the linked list faster than the other, but it's still going to be ahead in the list. I think as soon as we start talking about the solution, it'll make a little bit of sense. So we're going to start off by taking both of our pointers and we're going to set them both equal to the first node in the list, as usual. Now, step 2, we're going to take n equals to 3 right here. So n equals 3, we are going to use that, and we're going to say that we're going to advance the fast pointer 3 spaces through our linked list. So in one step, like this is going to be kind of a 2-part solution. In step 1, we are going to advance fast forward by 3. So we're going to say 1, 2, and 3. So now fast is pointing at orange. In that step, we didn't touch slow at all. So we're going to initialize slow, and then we're not going to touch it during this first phase. After we complete moving fast forward by 3 spaces, we're then going to enter the second phase of the solution. In the second phase, we're going to advance slow and fast together, one at a time. So both slow and fast will be getting advanced by 1 index. This is in direct opposition to how we treated fast previously. Remember, we had previously been moving fast forward 2 elements at a time. So this time, fast will move forward one element at a time. So we're going to move forward and move forward. We're then going to ask ourselves, is fast pointing at the last element of our linked list? In this case, no, it's not. So we're going to then move both pointers forward one more time. So we'll move forward 1, and we will move forward 1. We're going to again ask if fast is looking at the last element, and this time, yes it is. This is the last element, and we can tell that because the next property is pointing at null. As soon as fast is pointing at the last element, then that means that slow must be n elements behind it. So slow is now pointing at our answer, which is red. So in practice, this is not the worst solution in the world, just another one of these things where you gotta see the solution in kind of diagram format or just be told what it is. And then as soon as you have a good idea, well, it gets a little bit easier to code together. So let's take a break right here. I would like you to give a shot at the solution, and we'll join back up in just a couple moments and put the solution together in code. So give it a shot, and I'll catch you in a minute.